Hello everybody. Today we are looking at 11.3, which is volumes of pyramids and cones. Couple of things is it's going to be very similar to what we did yesterday or in the last lesson with volume of prisms and cylinders, except now instead of having volume being area of the base times height, our volume formula is 1/3 area of the base times height. This is the same thing that you will see on your reference sheet. You will see the volume formula for prisms. You'll see the volume formula for pyramids, okay? And then you'll see the volume formulas for spheres as well. But that's it, and they won't be labeled for which one is which. So the formula sheet's not great. But 1/3 area of the base times height. So it's just like what we did in the last lesson, except now we're just dividing our answer by 3. Okay, same thing for volume of cones, 1/3 pi r squared, which is area of the base times height. All right, so let's take a look. We have a rectangular pyramid with length 7 and width 9. So this right here is the base. Okay. And then the height of the pyramid is 12 feet. So my volume formula is 1/3 area of the base times height. Now, I want to show you guys something. Yesterday and then the last lesson, everything that we did was we said, okay, we're going to take that area of the base. We're going to come over here and say that my area of the base is going to be, length times width if we use this terminology. So my area of the base is 7 times 9. So therefore my area of my base is 63. Okay, so I could plug that in here. But I also want to kind of show you guys that you don't have to do the area of the base every time separately. I could say, okay, I have 1/3. My area of the base is going to be that length times width, then times height. Okay, so then I could do volume is 1/3, 7 times 9 times 12. Okay, this is my 63 for my area of the base, and then I could just multiply that by 12, then divide by 3. So here my volume is going to end up being 252 feet cubed. So you can do this whichever way you like. If you'd rather do the base out separately, go for it. If you want to kind of merge the area formula into here, go for that too. That's fine. Okay, so let's take a look at the square pyramid. All right, so volume is 1/3 area of the base times height. Okay, I'm going to go ahead with this one and merge my area of the base formula in because it's just a square. So it's going to be 4 times 4. And that is my area of my base. Okay, and then the height of the pyramid is 6. So I'm going to put all of that in my calculator and I'm going to get 32 inches cubed. Okay, let's take a look at part C for this example. Now, this one took me a minute to kind of see what was happening and how this was actually laying. Here I have a trapezoidal pyramid. So this is my base. Think of it as laying down on its side going backwards. So like the point is behind the trapezoid. So it's not standing on the base, it's laying on its side. So we are told that AB is parallel to CD. We know that AE, which is right here, is perpendicular to this plane. Now, why do I need to know this information? Okay, because if I know that AE is perpendicular to the plane, that means it's perpendicular to the base. That means that this is my height of my pyramid. Okay, because again, your height is always perpendicular to your base. So, with this one, it's going to be much easier to find the area of our base and then plug that into our area formula, because otherwise it's just our volume formula, because otherwise it's just going to get really complicated. So I have a trapezoid. So my area formula for a trapezoid is 1/2 height times base 1 plus base 2. Remember, this height refers to the height of the base. So we're going to ignore everything that's not on the base. So I have 1/2. The height of my trapezoid is 6, and then my bases are 9 and 18. Okay, so when I calculate this, I'm going to get that the area of my base is going to be 81. So now I can do volume is 1/3 area of the base times height. So volume is 1/3. We just found our area of the base was 81 times the height of my pyramid, which is 10. So when I calculate this, I'm going to get 270, and our unit is meters cubed. Okay. Let's move on here to example 2. Now let's take a look at cones. Okay. So my volume formula for my cone, again, is area 1/3. Area of the base times height, and that area of the base is pi r squared. So my volume formula is 1/3 pi r squared times height. So my radius is 5 and my height of the cone is 12. So I'm going to have 1/3 times 5 squared times 12 times pi. One thing that I want you guys to be really, really careful with is I saw this here and there. Make sure you don't put the squared with the pi, that your squared goes with your radius. Okay, because I saw a little bit of those mistakes here and there. So please just kind of make sure that you're squaring your radius, that you're not squaring pi. Okay, so when we calculate this, we are going to get 100 pi, and that's going to be centimeters cubed, because look at my directions, say both in terms of pi and to the nearest tenth. So I want my answer in terms of pi. Then when I multiply this times pi, I'm going to get 314.2 centimeters cubed. So these are the two ways that we want our answer to be given. All right, we're going to do the same thing over here. So my volume formula is 1/3 area of the base, which is pi r squared, times height. So I have 1/3. Now, I have my diameter here is 18. Usually, guys, just so you know, when you are drawn the entire thing, most of the time they're going to be giving you the diameter. Okay, so this is the diameter, which means that my radius is 9. So I'm going to do 9 squared times the height of the cone, which is 8, times pi. Notice I don't care that this is not like a normal cone. It's not, that perfect, oh, here's the point, here's the sides, they're all the same. No, it's a little bit, kind of crooked. That's fine. Okay, it's a little bit actually oblique. As long as we know the height, it's still the same, nothing changes. All right. So my volume formula, when I calculate this, remember, when we calculate it in terms of pi, I'm only calculating this piece. All right, so I'm going to do 9 squared. I'm going to multiply that times 8. Then I'm going to divide that by 3. And I'm going to get 216 pi, and that is meters cubed. Okay, then we're going to take that 216, multiply it by pi, and get 678.6 meters cubed. Okay. All right, I'm going to scroll down a little here. And we're going to look at this one. Okay, so remember, my volume formula requires the height of the cone. I do not have the height of the cone. 10, remember, is the slant height, which we use that cursive L for. So because I know the radius is 6, I know the slant height is 10, and I know that my height is going to be perpendicular, okay? I have a right triangle here with 6, h, and 10. So I can use my Pythagorean theorem. So h squared plus 6 squared equals 10 squared to find my height. So I'm going to have h squared plus 36 equals 100. When I subtract, I'm going to get h squared equals 64. And then when I square root both sides, I'm going to get that my height is 8. Notice that this is a 3, 4, 5 triangle that has been multiplied by 2. So if you know your triples, you could have skipped this step. Okay, now we can take our volume formula and go from here. So it's 1/3 area of the base, which is pi r squared, times height. 1/3, my radius is 6, so we're going to square that, multiply it by our height, and then move our pi here to the back. And then again, remember when I calculate just this piece to find it in terms of pi, I'm going to get 96 pi, and our unit is centimeters, so it's centimeters cubed. And then when I take 96 and I multiply it by pi, I'm going to get 301.6 centimeters cubed. Okay, so you might start to see, especially when we're dealing with cones and pyramids, that you have to do Pythagorean theorem to get the height of your pyramid and or cone. All right? Let's take a look at a composite figure. A composite figure, remember, is when you have more than one figure that creates your three-dimensional shape. So for example, if I look at this shape, I have a cylinder here and a cone here. So what I'm going to do is I'm going to find the volume of the cylinder, and I'm going to add it to the volume of the cone to get the total volume. Okay, so my cylinder formula is pi r squared times h. My volume of a cone is 1/3 pi r squared times h. All right, so let's take a look at just the cylinder. Notice they're giving you this whole line, which means that this is the diameter. So our radius is 2. All right, so I'm going to do 2 squared for my radius of my cylinder. The height of my cylinder is 2, and then multiply that by pi. All right, so when I calculate this, I'm going to get 8 pi. All right, then over here, I'm looking at my cone. Well, the base of the cone is the same as the base of the cylinder, so my radius is still 2. So that's 2 squared. Now, I know that the height from the base to the vertex of my cone is 5. Well, I know here to here is 2, which means that here to here is going to be 3. So the height of my cone is 3, and then we bring our pi to the back. When I calculate this, I'm going to get 4 pi. So my total volume is going to be 8 pi plus 4 pi, which is 12 pi. Okay. And this one does say nearest tenth. It doesn't say to do both, even though I always want you to go to pi first when you can. So that my total volume now is 12 times pi, which is 37.7 inches cubed. All right. Let's take a look at some of this in application terms here. All right, we have the Great Pyramid in Giza, Egypt is approximately a square pyramid with the dimensions shown. The pyramid is composed of stone blocks that are rectangular prisms. An average block has those dimensions, and we want to know how many stone blocks were used to build the pyramid. So what we're going to do is we're going to find the volume of the pyramid, then the volume of the average block, and then divide them out, okay? So what we're looking at here is volume of the pyramid. Okay, it's a square base, so its volume is 1/3 area of the base times height. And please realize that the Great Pyramid in Giza is one of the 7 wonders of the world. Okay, so when your numbers are big, expect it. It's okay. It's there. We're going to get large numbers here. Okay. So when I look at this, all right, so when I look at this here, we've got a square base. So my area of my base is going to be 230 times 230. So that's easy enough to just kind of slip right into our formula. So my area of my base is going to be 230 times 230. And then the height of my pyramid is 146. 146. There we go. Okay, so when I calculate this, I'm going to get that the volume of the pyramid is 257,446, 6.6 repeating. So our commas go here. Okay, and that's going to be meters cubed. Now, I want to find the volume of an average block. So volume is going to be, again, area of the base times height, because remember our blocks are prisms, all right? So we don't include the 1/3 because each block is a rectangular prism. So remember, since it's a rectangle, we can do that length times width times height because this is the area of my base. So I'm going to do 1.3 times 1.3 times 0.7. And when I calculate that, I'm going to get 1.183, and that's going to be meters cubed. Okay, so now that I have the volume of the pyramid and I have the volume of an average block, I'm going to take this number and divide it by this number. Okay, so I'm going to do that 2,574,466.6 repeating, which I have left in my calculator. So again, then I can be a little more exact, but it's not going to matter quite as much here because of where we're rounding to. And then I'm going to divide this by 1.183. All right, this is going to give me 2,176,218. Now, let's go back to the problem here for a second. We are rounding to the nearest 100,000, okay, which means we are rounding here. So the 7 is going to round it up, so it's going to be 2,200,000 blocks. Okay. Looks like blocks. There we go. Okay, so because we're rounding so high up, even if you dropped this, it wouldn't have mattered. Okay. If you have any questions on that, excuse me, please make a note of it. All right, we're going to do one more example here, which is going to talk about looking at fluid ounces. So we have a conical cup, has the dimensions shown, and we want to know how many fluid ounces does it hold. So the first thing that we're going to do is we're going to find the volume of our cone. Then we're going to convert it to fluid ounces because it tells us that for 1 cubic inch, it is 0.554 fluid ounces. So the first thing that we need is the radius and the height of my cone. All right, well, again, they give you this whole piece. So this is the diameter. So I'm going to take that 2.75 divided by 2, and I'm going to get 1.375 is my radius. Okay, now the next thing that we need is the height of the cone. All right, well, here's the height of the cone. I know that this piece is 1.375. I know that my hypotenuse is 5.5, so to find the height of the cone, again, we need to do Pythagorean theorem. So I'm going to do h squared plus 1.375 squared is equal to 5.5 squared. So this is going to give me h squared plus 1.890625 equals 30.25. When I subtract, I'm going to get that h squared is 28. We're going to kind of round off a little bit here, but again, I'm leaving the full number in my calculator. I'm not taking it out, but just to kind of write it down, I'm going to shorten it a little bit. And my height is 5.3254. Again, we're kind of rounding that off just a little bit as we write it. But again, I'm going to leave that number in my calculator. All right, so volume of my cone is 1/3 area of the base, which is pi r cubed, not cubed, excuse me, pi r squared times height. Okay, so volume is 1/3. My radius is at 1.375. We're going to square that and multiply it by the height we found over here, which is 5.3254. Again, we should still have this full decimal in our calculator. I am going to go ahead and multiply everything that includes pi because I'm going to take the volume and then convert it. So I need to know the full decimal, not in terms of pi. So when I multiply everything, I'm going to get 10.54344 inches cubed for my volume. Now, I'm going to take this number and divide it by the number of fluid ounces that are in every cubic inch. So I'm going to take that 10.54344. I'm going to divide it by 0.554. And I am going to, and it says round to the nearest tenth. So when I round to the nearest tenth, it's going to be 19.0 fluid ounces. Remember, if you are rounding to the 10th and you happen to round either up or down to a whole number, you need to have a 0 in that tenths place unless it was exactly 19 on the nose, which it wasn't. We rounded this to 19. So again, if you're rounding to the nearest tenth and you happen to round so that it's a whole number, make sure that that 0.0 is there in that tenths place, because again, that shows me that you rounded to 19, that the number was not exactly 19. Okay, so if you guys have questions on anything, make sure you make a note of them somewhere on your paper so that way you can ask me in class. I will see you guys later, and I hope you have a wonderful day.